Okay, our next lesson is dealing with solving quadratics. So what is our goal today? The goal. I can solve quadratic equations by choosing the most efficient method, factoring or quadratic formula. So I know people don't like factoring. However, factoring can be a little bit more efficient than using that quadratic formula. So again, you've done this already. It's still technically review material. So as we move through, most of this should seem somewhat familiar. So factoring. Let's just talk about, first of all, how you solve with factoring. So factoring, remember, you're taking a three-term expression and you're getting it down to a pair of brackets. So before, so I'll say previous, what you were doing, you were taking x squared. You're taking x squared plus 6x plus 8, for example, and you were moving it, or factoring it, down to an x plus 4, x plus 2. And this is what we would call an expression. All right. Now I want to move to equations. All right, so we were just working with expressions previously. Now we're moving to equations. How's that different? Well, we're still going to have the x squared plus 6x plus 8, exactly what we did over here. The difference being this time is that there is an equals 0 there. So when we do our factoring, as we did on the left side here, it's still going to be x plus 4 and x plus 2, but we still have that equals 0. So before, it wasn't equal to anything except for what it was on the previous line. That's what the equal sign was saying. This is what it was equal to previously. Now we're saying that whatever we're doing on the other side, it's got to equal 0, and these are equivalent expressions on this side. Excuse me. So the purpose of getting it this far is so that we can solve. So just a quick aside down below here. So what are we essentially doing? What I'm telling you is, I'm telling you that I put a number in this box, which we can't see in, and I'm multiplying it by this circle, and I'm telling you that whatever number is in the box and whatever number is in the circle is going to result in it being a 0. Now you know from multiplication that the only way you can get something to multiply to 0 is that one of the numbers has to be 0. So that would mean, your conclusion, either the number in the closed box is 0, or the number in the closed circle is 0. So what we're doing with factoring is that this x plus 4 is our box that we can't see in, but actually we can see in our brackets. So the question is, what would make that expression equal 0? So we're looking at what would make x plus 4 result in a 0. What x value? So the x value that would make x plus 4 be 0 is that the x would have to be the opposite, the inverse. It would have to be a negative 4. Similarly, in order to make the circle be 0, this circle to be a 0 would have to be an x value that would make it 0. It would be the inverse of that, so x plus 2, the opposite of plus 2, would be minus 2. And there we go. So that would be our solution for our equation. So we're simply determining, once we get it into factor mode, what value of x would make this 0, what value of x would make this 0. And for more complicated ones, I'll show you a process that will help us out. So here are some examples by factoring. So some of them have been mixed up. They're in a different order. So sometimes you got to move them around. So this first question, we need all the terms on the same side. So I'm going to use my algebra skills, and I'm going to subtract 22 because I want it equal to 0. I'm going to subtract 22 from both sides. There's no common term, so it's just going to be x squared plus 9x minus 22. Now I go through the process of what type of factoring is this. Hopefully by the amount of time you've done all that factoring in the practice, you'll realize this is a simple trinomial. So let's go ahead and try it as a simple trinomial rather than jumping to doing a quadratic formula. So when I look at this, two numbers that multiply to 22. So 1 and 22, that won't work. 2 and 11, That'll get me a 9. So 2 and 11. They have to add a positive 9. So that means if I have negative 2 and I add 11, I will get a positive 9, and it's x and x. So there we go. So that's simple trinomial. All right, it's a simple trinomial. So now you got to take this one step further, and we're using the set notation. That's the squiggly brackets. That tells us that x has multiple answers. So what would make that first bracket? What would x have to be to make this 0? It's got to be an inverse. So x would have to be a positive 2. I'm going to put the positive 2 to emphasize. You do not need to write the positive sign. X plus 11. What would make it 0? The x would have to be a negative 11. So there we go. Moving on to my second example. Okay, the second example, again, it's got to be equal to 0. So that's the first thing I'm going to do. I got to move that 30x over. And I'm going to put it in order of decreasing powers of x. So I'm going to have 9x squared. Next, I want my x term. So I'm going to insert the negative 30x there. Plus 25 equals 0. Going through my checklist, I know that 9 and 25 have nothing in common, so it can't be a common factor. It can't be a difference of squares. There's 3 terms. Could it be a perfect square? Well, I can take the square root of 9. X times x is x squared, so it works. Positive 25 is 5. Okay, so far it could be a perfect square, so let's check that out. So 9x squared, square root would be 3x. Square root of 25 is 5, so that gives me 15x. If I take the 15x and I double it, I get 30x. And negative 30x. I can work with that. It's good enough. So it is perfect square, so that means I will have 2 sets of brackets. It's going to equal 0. I know it's going to be 3x and 3x. I know it's going to be 5 and 5, but it has to go to negative 30, so both signs are going to be negative. I'm not sure why I did that, because you're probably asking yourself, isn't this just 3x minus 5 squared? Absolutely correct. I apologize for the mix-up, but yeah, that's what it should be. All right, let me jump right to that final step. I'm just going to erase this one for space purposes. Okay, I need to find out what will make the bracket, what value of x will make the bracket 0. Now, some of you are going to be saying to yourself, I don't know, I can't do this in my head, and that's fine. So what we're going to do, we're going to take what's inside the bracket, 3x minus 5, I'm going to do it off to the side. So I'll put a star and a star, show you it's over here. So I take the 3x minus 5, I'm going to set it equal to 0. Okay, so I'm just looking at inside the brackets, using my algebra skills, add 5. So I'm just going to isolate or solve for x, divide both sides by 3. I get x equals 5/3. And there's the answer. It's 5/3. Now the shortcut is the constant divided by the coefficient. So there's the 5 over 3. And it's the opposite sign of what's there. So a negative, it's a positive answer. If you don't remember that, this process works every time, and you're not going to be penalized for using it. Okay, so whenever you get a bracket that you can't just tell the answer to, simply do that off to the side. Okay, number 3. It's already equal to 0. So let's go through the checklist here. Common factors, 2 and 5, not a good thing. It's not a difference of squares. Perfect square, I can't take the square root of 12, so that's off the table. It's not a simple trinomial because 12 is in front of the x squared. So my only option is complex trinomial. So off to the side, 1 and 12, 2 and 6, 3 and 4. That's it. So I get 12 and 1, 6 and 2, 4 and 3. Factors of 2 are 1 and 2. So let's see if we can find something that will give us a 5. So 2 and 12, that won't work. 4 and 6, that won't work. 6 and 4, that won't work. 24 and 1, that's not going to work. 12 and 2, that's not going to work. 8 and 3, that'll work. If I have an 8 and a 3, I can get a negative 5 by making it negative 8 plus 3. So that tells me that these two terms are together and these two terms are together. So I'm going to end up with a 4x with the 1, a 3x with the 2, and now which is negative, which is positive. Whatever multiplies to 8 is negative. So 4 times 2, when I do distributive law, 4 times 2 is going to give me the 8. It has to be negative, so that means that's the negative, and that's the positive. Oh, and I have way too many equal signs. Whoa, that is a huge error. 1 equal sign per line. Not good. All right, so now I need to make each of these brackets equal 0. If you can do it in your head, you go ahead and write final answer. If you're not able to do it in your head, then you have to use the process I listed off to the side. So I know that it's going to be the constant over coefficient, so 1 over 4. And I know the sign's going to be opposite, so it'll be a negative. Similarly for the next one, constant over coefficient, opposite sign. So there are my two answers. And if you can't get that just by looking at it, then you need to use the process discussed over here. Okay? All right, and the last one very quickly here. 9x squared minus 25. No common factors, but there's only two terms. So it's got to be a difference of squares. If it's not, it does not factor. So the 9, yes, 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 and we have subtraction. It is a difference of squares, which means it'll end up with two brackets. So 0. So I'll have a 3x to start off both sets of brackets. I'm going to have a 5 and a 5. I'm going to have a positive. I'm going to have a negative. So the answer is going to be very similar. It's going to be the constant over coefficient. So constant is 5. Coefficient is 3. In the first bracket, it's a positive. So I'll have one that's a negative answer. Here I have a negative, so that means the other one will be a positive. So what we do is we say the answer is plus or minus. So plus or minus stacked on top of each other. It tells me that there's two answers. One's a positive version, one's the negative version. So this is the first half of the homework. It's solving questions by factoring. So you have to do a little bit more factoring, and you need to be able to take it to that final step.